Hi all, this is Hani. Welcome back to our channel Code with Hani. Today we are going to solve September day 16 LeetCode challenge, which is replace non-coprime numbers in an array. So we will be given an array of integer nums and we have to perform the following steps. So we have to find any two adjacent numbers in nums that are non-coprime. So if they are non-coprime, we replace them with the LCM. If not, we have to stop the process. So repeat this process as long as you find the two non-adjacent non-coprime numbers. Got it? So we have to return the final modified array. It can be shown that the replacing adjacent non-coprime numbers in any arbitrary order will lead to the same result. Okay. So yeah, the test cases are generated such that the value in the final array are less than or equals to 10 to the power of 8. So non-coprime number is nothing but two values x and y are non-coprime if GCD of x and y is greater than 1. So GCD is nothing but greatest common divisor. So here 6 and 4, they have a GCD greater than 1. So we have to replace with 12. So 12 and 3 also coprime. So we have to replace it with 12 again. So 12 and 2 also no or also coprime. So we are replacing again with LCM of 12 and 2, which is 12. So then 12 and 7 are not non-coprime. So it has a GCD 1. So then we are checking 7 and 6, that also doesn't have GCD greater than 1. So they are not non-coprime. So but 6 and 2 are non-coprime because their GCD will be greater than 1. If you take the LCM of 6 and 2, it is 6. So 12, 7, 6. So these three, if you take, it will not have the GCD greater than 1. So we have to return this final modified array. Now just take a look at the example and how we are going to approach this question. Got it? So yeah, this is the example that I have taken as we have discussed just during the if you see, we have to, let's assume. So if you see, you have to take any two numbers and you have to find out their GCD. So if you find out the GCD and if it is greater than 1, you have to figure out the LCM. And LCM of that next number will be this and this, right? Until if it is not two numbers, until you don't find any two numbers have the GCD greater than 1, you have to keep on modifying. So 6 and 4 would have modified by 12. So 12 and 3 have again GCD greater than 1. So again LCM will be get updated to 12. So like this we have to do. So what we were thinking, we have to pop out the example when our case comes 12, 7 were not coprime, right? So we will be updating the new array only with elements which are not coprime, right? So now when you are going to insert 6, that will also not coprime of this 7, right? So but when 2 comes, okay, first you have to pop out, you don't need to check because 2 6 only is adjacent, right? So you have to pop out the last, and if these two are not coprime, then what we will be doing again, we will be checking the LCM and will be updating until, so once you update this again you will check this and this. So you need only the last element of the new array. So if you need the last element to check with the previous answer every time, what we will be doing will be, we have stack, right, to always check what is the last element and whichever the element we are going to insert. So by then we will be knowing, okay, the last element and the current element which we are going to insert. If you figure out, for example here as well, here we would have updated to 12, right? So the stack would have consist of only 12 because we would have modified, right? So once we have 12, now we are going to insert 3 into, we are thinking to update the array to add 3, but 12 and 3 are not coprime, right? 12 and 3 are non-coprime. So again we will be figuring out the LCM. So for that what we will be doing, if it is before inserting itself, before you are inserting this 3, if some stack exists, okay, any element in the stack exists, you will be checking the element you are going to insert is 3. Okay, so if the stack of -1, so you have to figure out GCD of stack of -1 and your number which you are going to insert. So if you have figured out, then it is greater than 1, which means these both are non-coprime. So in that case, what we will be doing, we'll be popping this as well out, right? So you'll be popping the num as well, or stack dot pop you will be doing, which is num1, and you have num already. So if you know the GCD of any number, you can take, if GCD of two number, num1 and num2 you figured out already, so then LCM you also do the same way, num1 star num divided by GCD will give you the LCM. Okay, this is a mathematical proven formula, you can verify. So GCD of a number you can get it like this, or you can use inbuilt function math.gcd. Also you can just pass the num stack of -1 and the current num which you are going to insert. So once you figured out the LCM, this only you have to insert, right? So this LCM is the new num. Okay, now you update the stack dot append num. So now what we would have done, you would have popped this element also out, and the 3 would have, so 12 comma 3 give you LCM as a 12. Now again what you will be doing, this was popped out when you are calculating the LCM, we would have popped out, right? Stack dot pop we would have done. Now okay, 12 and 3 are non coprime. So what we will be doing now, we figure out the LCM, that will be our new num that you are going to append that num. Now again it is at 12. So this is how we are going to do consecutively until either, as they told, the GCD should be equal to 1. If any GCD was 1, then you can break the loop. Okay, because obviously we would have updated the array with only the not non-coprime numbers, right? So if any GCD was, if this doesn't have the GCD equal to 1, this also will not have, because already we have inserted in such a way like which are not non-coprimes. That's how the condition is, right? So yeah, basically this is what we have to check. We have to insert into the stack only when it is not non-coprime. If stack was there, you will be keep on popping out that element and the element which you are going to insert. Yeah, I hope this is clear to you guys. Yeah, let me show the full solution and we'll just run through the example. Okay, now as you guys see, this is the working solution that we have submitted to solve this question. So we have initialized the stack. Why we are using the stack? Because we always want the last element which is in the mod return, which we updated in the array, and will be the element which we are going to insert. So any elements, if 12, 6, 7, something like that, now the element we are going to insert, that should, they have mentioned in what they have mentioned, that two adjacent non-coprime numbers have the GCD greater than 1, then you should find out the LCM. So two adjacent means, so already you have a array 2, 6, 7, something like this. Now we are going to insert, so you want to verify the last element, right? So if we have stack, so we can easily pop it out, or we can compare, right? Stack of -1. So yeah, but if initially the stack is empty, okay, now we have the stack, no, so we'll be updating our num. So initially our stack will consist of 6. Okay. So when another 4 comes, okay, for 6 and 4 will have GCD greater than 1. So what we will be doing, will be popping out 6 Okay, stack.pop will pop out the 6. And what is our current num, which is 4? So the GCD will LCM will be 12. Okay, now that was our new num. Okay, so what we will be doing now, 6 got popped out. Now we will be updating it to 12 the same way. Next, 3 will come, right? So when 3 comes, stack of minus 1, 3 and 12 will have GCD greater than 1 again. So we will be popping out the 12. So 12 comma 3 will have a LCM 12. So we'll be updating the 12. Next, 2 comes. So 12 and 2, see, stack of minus 1 now has 12. So 12 and 2 also has GCD greater than 1. So our LCM now will get updated to 12 again. So 12 to, so as we know na GCD, so now LCM of 12 and 2 is again 12. So you will be updating it to 12. Got it? Now when 7 comes, okay, 7 and 12 doesn't have a GCD. Stack of minus 1 is 12 and the num is 7. So 12 and 7 has a GCD 1. So it will break the loop. So now we will be updating our num. Got it? So this is the stack now. So next 6 will come. So 7 and 6 also have the GCD same one. So stack of minus 1 is 7, num is 6. So 7, 6 will have GCD 1. So it will break. Now it will get appended. Next, when 2 comes, so stack of minus 1 is 6 and numbers 2. 2 and 6 will have a GCD greater than 1. Have GCD greater than 1. So what we will be doing will be popping out the 6. Okay. So 6 and 2 will have a LCM of 6. Okay. Now whatever the LCM we are figuring out, that will be our new num, right? So now we are updating that to stack. Okay. Now our new num is 6. Okay, earlier it was 2, now it was 6. So now again what will be our new num is 6. We'll check. Now stack of minus 1 is 7 comma 6. So 6 and 7 have a GCD 1. So our num is already uh, 6 with an LCM of previous 6 and 2. Now we'll be updating that 6. So this will be our final result array that will be returning 12, 7, 6. Got it? I hope this makes sense and clear to you guys. So here, as I mentioned earlier, you can use GCD, or you can write a GCD function on your own, or you can import it via math. Both will work. So yeah, this math.jcd intern runs this code only. Maybe in the interview, if the interviewer asks you to find out the GCD, you can use GCD of a comma b. You will be keep on swapping a and b, a as a b and b as a mod b, so that you will be getting the GCD value. I hope you will know how to calculate the GCD. Even if not, you can just run through any two numbers, 6 and 2, 7, 6, something like that, so that you will be understanding how this GCD works on your own. Yeah, I hope this is clear to you guys. So basically, what we are doing, we have to compute two non-adjacent elements which has a non-coprime or not. If it is non-coprime, you have to take non-coprime is nothing but whose GCD is greater than 1. So you need the last element which you have in your new resultant array. Okay, if the stack has the element, you will be checking the last. So you are going to insert some element into this by traversing through the nums. So when you are going to insert, if already some elements present and you are going to insert some new element, if you need to verify that both will be in the adjacent, right, in the resultant array which we are going to return. So we have to compute that too by checking stack of -1, we know that is the last element, and the current number which are going to insert is the new element, will be in the resultant array. So we'll be computing those GCD if it is greater than 1. Okay, then these both are non-coprime. We have to pop it out and we have to insert the LCM. So we are modifying the num by popping the last element and the num, then that is the new num. So if that new num and previously existing, so now if you popped out, we have to verify, right, that is not interfering with any of the previous not non-co-prime numbers, right? So what we'll be doing will be going and checking until the GCD equals to 1. If the GCD is coming as a 1, if then we know previously also we would have inserted the same way. The difference between these the GCD between two these elements will be 1. Like that only we would have inserted. So if this both were coming as a 1, so we know obviously we don't need to verify further because that both also will be 1. I hope this is clear. The time complexity will be running through the each nums, and to the max we will be checking out the in the stack, right, whether the GCD is there or not. So the GCD computation will be order of log of mean of a comma b. So because you are keep on doing a mod b, right, so that's why it will be decreased exponentially, and it can be min of a comma b, whichever is less. So order of log of mean of a comma b will take for GCD computation for each. So 2n operations. Example, we'll be obviously computing two numbers and we'll be pushing into the array. Next, for next number we are checking the, it's not like always it will be n, right? So to fill this array to the max, it can go to n to figure out the modified array. Sometimes everything can be not non-coprime, so it can be modified, so you don't need to verify each and time everything, right? So yeah, so to the max it can run order of 2n operations, means will be running n, which means order of n. So what this operation will be find computing the GCD, right? So for that what will be, so n enter log will assume m for this. Let's assume m will be the number of times that. So n enter log m will be our time complexity. Got it? So the space complexity will be order of n because we are storing the stack that may contain all the elements if they are not non-coprimes. Yeah. Since it may look like we are popping it out every time and we are pushing it every time, but to the max, the element might be any element might be pushed once and popped at most once, because uh, so if we once you popped out it is lost, right? So for anything, yeah, while we are computing to the max, the stack push and pop operation can happen only at the order of n. For example, if you yourself know, right? So 6 comma 4, you would have pushed a 6. When 4 comes, you wouldn't have pushed. So you would have popped this and you would have computed the LCM and you pushed it 12. So this 12, so now you pushed 2 times. So when 3 comes, we popped 12 and 3 and pushed once. So the same, pushed 12. So when 12 and 2 comes, so we popped 12 and pushed uh, LCM of 12 and 2. So the same, when 7 comes, it was not coprime, non-coprime, so we just inserted. So when 6 comes, so to the max, we will do push and pop operation to the max or less than or equal to n. So that's why the stack operation can happen n times the nums we are traversing n. So that is why we are putting that to the max. It can run through order of 2n operations, so it's not n square. Got it? It may look like, but if you just see anything, because we are keep on popping it out, and to the max will do for any number one push and one pop, okay, at order of 1. So the stack will run through only order of n times. I hope this makes sense why we are putting to n operation. So this is the exact solution that we have used to solve this given question, and yeah, it passes all the test cases successfully. If you have any questions or feedback, please feel free to leave a comment below. I'll be glad to assist. The GitHub link to the solutions will be provided in the video description for your reference. If you found this video helpful, I would truly appreciate if you could like, subscribe and share it with your friend. That will keep me motivated to do more videos daily. Yeah, thanks for watching.